start to look at a biological structure and look at the urban sites. This is the next building, is the Skyline building, which is completed now. The pattern that we had was the tree pattern, and the idea was that the tree had a series of sky courts. And when we designed the building, the first thing we did was to look at its ecological context. It's right in the middle of Kuala Lumpur, so there is no immediate vegetation. And what you can see on the bottom square is the green areas, in which ecology gives us clues on what species to bring back. So the building is basically a spine that we have in the middle with the sky courts at the edge. And these are we start to look at what vegetation to put into the building and what are the faunal species we want to attract. And so for the lower floors, we wanted to attract dragonflies and butterflies. For the middle floors are the songbirds, and the upper floors are the migratory birds. We wanted to make the top floor into a pleasure zone, a happy zone for people. And we had a number of pools. The top floor had 4 pools. We have the number 1, which is the lap pool. Number 2 is the children's pool. Number 3 is the family pool. And number 4 is the jacuzzi pool. 5, 8, and 7 are decks for entertainment. And 6 is an open air amphitheater. So the whole floor is for entertainment, for recreation, and for enjoyment. And that's what we try to do with our projects, to try and give pleasure to people in the design. But if we go back maybe about 10, 15 years earlier, this was the building that we did in Tamandu. At that time the client was IBM, and IBM, if you remember, the logo had blue lines, and so the horizontal lines were blue. And we wanted to have a continuity, but we couldn't achieve total continuity. There was a stepping stone relationship in the sense that the vegetation is a series of planters which are linked by trellises. And then a few years later we did the Dato building, where we had a series of sky courts at the corners which are not connected. And around that time we started to think of what does it mean to design a bioclimatic skyscraper. So the key factors were that the lift lobby is naturally ventilated, the toilets, the staircases were naturally ventilated, and they're not in the center of the building, not the central core position. And so we started to look at how the core position can improve the thermal performance of the building. And the right-hand side is a diagrams of different core positions to the side, to the end. But we found that the core position on the east and west side had the lowest air conditioning requirement. And so this justifies the shape of the building. Well, at that time we also did the Messenger building. We wanted to create multi-story sky courts, which are about 3-story. And this was finished in 1992. The owners didn't really look after the building, didn't believe in spending money on the building, and so we went down to material issue. On the right hand side you can see plans for the building, you can see the sky courts that climb all the way up the building. So there's again the principles of the bioclimatic skyscraper is there. Naturally ventilated lift core, staircases and toilets. So this was an early experiment in about dynamic design. In fact, all our buildings are experiments to try and advance architecture in ecological design. I started to look into how do we use plants to improve indoor air quality. And so this is the tabulation. On the left-hand side are the list of the internal air pollutants. On the right-hand side are the list of plants that absorb pollutants. So when we designed the conference room for the Australian Embassy, we used peace lily to absorb the pollutants on the left-hand side. In planning we did this building where this time we got vegetation from the inside, stepping up to the top of the building. And this is a building in Korea where we did this, almost the same thing. But what nature does for us is what we call, it provides ecosystem services. In other words, nature creates energy by photosynthesis, it absorbs pollutants, through sequestering, detoxification of human industrial waste. Now, the idea of biomimicry is to imitate and replicate the processes of nature, but it became clear to me that it's not possible for us to use technology to compete with nature, because nature is so vast and it does it by itself without any inhuman intervention. So then the thought was that if you cannot imitate nature, replicate it, you should augment it. It also became clear to me that if you were to augment and use nature to provide ecosystem services, the nature has been as close to the urban realm as possible. So you should change, for instance, from the left-hand diagram to the right-hand diagram. So it was the need to bring as close as possible. So the idea was to weave nature with the urban realm. As you can see in the left-hand diagram, nature is the green, and the urban realm is the yellow. And this was the master plan for the island of the Reunion, which is east of Madagascar. And you can see the urban fingers which go out. On the left-hand side is the green spine that collects the vegetation from the waterfront, and we brought it into the inland. And then the urban fingers are being woven in between. And in this way, the urban fingers and the green areas are sufficiently close together within about 30 meters or so that the ecosystem services, the remediation of air, production of photosynthesis, and so forth can benefit both the green and the urban areas. So here we are, you can see aerial view of the vegetation that is brought in, and in between are the urban fingers, so they all meet together. And for the roads going across perpendicular to these fingers, we didn't want to cut the fingers, so we have what we call eco undercroft. That means that the vegetation goes underneath the road, as you can see on the diagram on the right-hand side. Then the edges of the vegetation should not be pristine because species don't like sharp edges. We need to make it serrated so the species can hide, they can, from prey, they can breed and so forth. And so this is the concept of the vegetation edges. Then we start to look at hydrology, because hydrology is important. when astronomers look up into the skies at different planets, the first thing they look for is what the science of hydrology is that water, if there's water, there's organic life. So this is a master plan for a project that we did in Bangalore, in Bangalore. And the idea was to bring the vegetation from the edges and bring it right across the site. This is the water circulation system. The idea was to close the loop within the buildings, and where it goes outside, we bring it back into the soil, into the ground, through constructed wetland. And these are different ways of doing it, through rain gardens, drainages and so forth. But for the black water, we have what we call monosphere, where we construct a wetland where the water goes through a series of ponds, and that with each pond it cleans the black water rather than treating it mechanically as what we're doing now in most of our buildings, in most of our structures. And so here it says we bring the vegetation as close to the buildings as possible and bring it to the edge of the building so that it can connect to other green areas within the same locality. So here the green shows the different vegetation that comes across the site. And where it is bifurcated by roads, we have eco-bridges that links the building, the vegetation on one side to the other side. Now for energy systems, we started looking into how we can design not from existing systems, but to what we call surplus energy. The first approach is to try and use bioclimatic design to create a low energy building without any mechanical electrical systems. And then from there, we lower the improved pump condition using what we call mixed mode, where we have ceiling fans and side fans. And then, of course, full load would be where the conventional building is. We should try and make it smart systems so that it is low embodied energy and low operational energy. Then you have productive mode where you generate your own energy by renewable resources. And finally, fifth would be where you have surplus energy. So in a nutshell, you can see stages 1 to 5 is a process for designing a low energy building. The first step is really for, especially in the tropics, what we call bioclimatic design, where we use the shaping of the building, the orientation, the facade design, and other features to make it a low energy building. So this was a house that we did a little bit earlier, back in 1985 or so. But the idea was to have a canopy over the building. And this is the canopy at the top. It lets in the morning sun, keeps out the afternoon sun. We got a scientist to measure the temperature. You can see the outside temperatures of 35 degrees. Around the pool, which is about 32. The upper roof is 33.8. First floor is 30.6, and the ground floor is 30.5. And so we were able to use the canopy to lower the ambient temperature, but certainly we cannot get up to 23, 24 degrees, as with any air-conditioned spaces. And so, but by lowering the ambient temperature, we reduce the energy consumption of the building. And the swimming pool then becomes the evaporative cooling device for bringing ventilation to the building, bringing cool air into the building. And we look at the building as context veritas within the surrounding buildings, which were also designed by us a few years earlier. Another canopy approach is this station where we have a series of modules which are linked together. And this is the ticketing space and public space. This was our master plan for the University of Malaya.